Today we have a very important topic on hand. We are going to study about unit circle. But before we see what a unit circle is, let us first find out why we need the concept of unit circle. For that, let us start with something basic. Now, how did we define sine theta? For any acute angle theta in a right angle triangle, sine theta was defined as opposite side by hypotenuse. But then, do you notice such a definition has a very serious limitation? What is that? Your theta has to lie between 0 and 90 degrees. What if I have to find out sine 90 degrees? How do I do that? This theta, if it takes the value 90, then your whole figure is going to look like this. There is going to be no hypotenuse. Or how do I find the value of sine 420 degrees? It is impossible to envision such angles to be a part of a right angle triangle because the sum of the angles of a triangle has to be 180 degrees. Now, that is where your unit circle steps in. With the concept of unit circle, you can find the trig function values of angles which are greater than 90 or less than 0, or in other words, the negative angles. Now, this is just one very simple feature of unit circle. It is much more than that. That is why unit circle is a tool of trigonometry which is used in architecture, astronomy and many other sciences where you have to find a relation between angles and heights or distances. So as I said, this is just one very small feature of unit circle. We are going to see what a unit circle is and how to find the trig function values of any angle on the earth. Shall we start our class? Now let us start with some basic information that you need to know to learn about unit circles. Here your coordinate plane x-axis, y-axis intersecting at a point known as the origin denoted by such an ordered pair. Remember, any point in this plane should not be written like this or like this. Any point in this plane is an ordered pair. It has to look like this with an x coordinate and a y coordinate. And what do these two axes do? They divide the plane into 4 quadrants. And the sign of these two, the sign of the x coordinate and the y coordinate, depends on which quadrant it falls. Now to the main topic on hand, our unit circle. This is what we have been so far talking about. A simple circle. In the xy plane, its center is the origin and its radius is 1 unit. What do we mean by 1 unit? If you are making a toy, it is 1 millimeter. If you are building a bridge, it is 1 kilometer. Whatever it is 1 unit. Next, what you have is the standard notation for drawing an angle. Your initial ray will always be the positive x-axis. Is it something new? Of course not. This is how you have been drawing angles all your life. What is an initial ray? Whenever you have an angle, there are 2 sides related to it. The place where the journey begins, the place where the angle starts its journey is called the initial ray. Where it ends is called the terminal ray or the terminal side. Throughout this topic, what we are saying is that whenever we talk about an angle, it will start its journey from the positive x-axis. Now, is it something new? Of course not. If I ask you to draw a right angle triangle, will you draw it like this with the negative x-axis? No. You will always draw it like this. Your journey will always start from the positive x-axis. What is the second one? For positive angles, go in the anti-clockwise direction. For the negative angles, go in the clockwise direction. What does that mean? Your clock moves like this, from top to bottom. What we are saying is that for positive angles, go in the anti-clockwise direction, in the opposite direction, from the bottom to the top. If I ask you to construct a 90 degrees, will you construct it like this? Will you start it from the positive x-axis and will you go down? No. You always go like this, from the bottom to the top, or in other words, the anti-clockwise direction. But if you want negative angles, go down. So what I mean is that if I have to draw 30 degrees plus 30 degrees, I will draw like this. The journey begins from the positive x-axis, goes like this. If I want to draw a negative 30 degrees, minus 30, my journey still has to begin from the positive x-axis, but it will come like this. From top, it will come to the bottom, and the minus 30 will look like this. This is what I mean. This is going to be the standard notation. Throughout this topic, you will see that the journey of your angle always will begin from the positive x-axis. Now, for any angle theta, its terminal point is cos theta sin theta, such an ordered pair. What is the terminal point? Here, your initial side, it goes and ends its journey here, which is the terminal point, and the point where the terminal side meets the unit circle is known as the terminal point. Now, this is any xy, right? Or in other words, if you have such an angle, say 45 degrees, if this is 45 degrees, then this point has to be 1 by root 2, 1 by root 2. It cannot be a random 7, 11 or something like that. It has to be this. Why? It is a very simple proof. Now, how do you locate such a point, the ordered pair 11, 3, in the xy plane? What does this mean? This point lies 11 units along the x-axis and 3 units along the y-axis, and the place where they meet is 11, 3. Now, if I draw a perpendicular line, then this line, this much distance will be 3 and this much distance will be 11, right? So, if I draw a perpendicular here, then this much distance will be y and this much distance will be x. So, what will be sin theta? Sin theta will be opposite side by the hypotenuse. What is the hypotenuse? What do we call the line joining the center and a point on the circle? It is the radius. So, there. Sin theta is y. Similarly, we can find cos theta, which is the adjacent side by the hypotenuse, which is x. So what have we proved? The place where it meets is actually cos theta sin theta. It is not some random point. Now, what are the angles made by the other positive and negative axis with the main initial ray, with the positive x-axis? What are the angles made? First, when it has not gone anywhere, it is just 0. It has not covered any distance. Then a 90, then a 180. It completes its journey at exactly here, 360 degrees. When it completes its journey, one complete revolution, it ends at 360 degrees. Now, what about their terminal points? What about the points where they meet the unit circle? Here you have your x-axis, which means what? Y coordinate 0 and a +1 here, a -1 here. Now, what is this? Your y-axis, which means what? The x-coordinate is 0, then a +1. From here a +1 and from here a -1. What does that mean? Any line which makes an angle 0, its terminal point is 1, 0. That means cos 0 is 1, sin 0 is 0. Similarly, any line which makes an angle 90 degrees with the initial ray, its terminal point is 0, 1, which means what? Cos 90 is 0, Sine 90 is 1. So I have written down all the other things. It just follows, right? So remember, 360 degrees takes the same value. Your cos 360 degrees is 1 and sine 360 degrees is what? It is 0. Remember, this is a very, very important point. Unit circle also demonstrates this point. What is it called? It is called the periodicity. It means, what do you mean by, for example, you have periods, you have maths period, you have science period. What does that mean? After a certain time period, the phenomena, whatever you see, it repeats itself, which means your sine and your cos, both your sine and cos, they have a period of 360 degrees. After 360 degrees, the same value follow for sine and cos. If it follows for sine and cos, it will also follow for cosec and sec, right? All the four of them, you will see that their values start repeating themselves after 360 degrees. What do I mean by that? If you have say sine 30, now just add a 360 to it, then what will you get? This is what it means. To 30, if you add a 360, the value will be same. Sine 30 is 1 by 2, so sine 390 will always be, it will be the same value. That means after 360 degrees, the values just keep on repeating themselves. That is exactly why we have chosen a circle. For example, now if I have to mark say 420 in the unit circle, how will I do that? Here one journey is finished. It has finished 360, right? So what will I do with 420? How will I represent this? Just do minus this. So what will you get? 60 degrees, right? So take an angle 60 here. This will be your 420. The same position, the same trig values, everything is same. Why? Because it is a periodic. Your sine and your cos functions are periodic. After a certain point, they just keep on repeating their values. So if you are breaking your head thinking, oh my god, 360 ends here, how will I denote 420? No problem. Just subtract 360 from here, draw a 60 degrees. Now it is, what if it is something even bigger, say 765. How do you do that? 360, finished. Go once again, then you will get what? A 720. 2 rotations, 360 into 2, which is what? 720. Now subtract it. What do you get? You will get a 45 degrees. So what does that mean? This angle is situated in the exact position as 45. Not only that, all its trig function values will be exactly the same as 45 degrees. So if you have such big angles, do not worry, just express it in terms of 360 degrees or its multiples, into 2, into 3, then you can locate them in the unit circle. Now this is a chart to find where all your trig function values will be positive. In the first quadrant, all the trig function values are positive. Why? Because your sine and your cos are positive, which means sec and cosec and cot and tan and all of them are positive. But here what happens? Your sine value and its reciprocal, which is the cosec value, only sine and cosec will be positive. All the other values will be negative. Cos and sec will always be negative. Why is that? Look at the x coordinate. X coordinate represents what? The cos values. If the cos value is negative, that means what? The sec value becomes negative, the tan value becomes negative, the cot becomes negative. So only sine and its reciprocal will be positive. What happens here in your third quadrant? Only tan and its reciprocal, which is what? Cot. Only tan and cot will be positive. Why is that? Here your sine is negative and your cos is also negative, so it gets cancelled out. So only your tan values and your cot values, it's a reciprocal, will be positive. All the other trig function values will be negative. What about the angles which fall in this quadrant? For all the angles which fall in this quadrant, what you will see is that only their cos and its reciprocal, which is sec, only those two trig function values will be positive. All the other will be negative. Your sine will be negative, your tan will be negative, all the others will be negative. Now comes the main part, the part where the unit circle makes our calculations and our life easy. What was all this about? If your angle is an acute angle, no problem with that. Sin theta is very well defined if your theta is an acute angle. What if your angle falls in any of the other quadrants, or in other words, what if it is a non-acute angle? Then you have something called the reference angle. What is it? For example, give me a non-acute angle, say 150. Suppose you have 150, this much. It starts its journey from the positive x-axis and travels like this. It is a 150 degrees. Then we have something called the reference angle. Reference angle is the acute angle made by the terminal side. This is the initial side. Now this is the terminal side. The angle made by the terminal side and the horizontal axis. What is that? The angle made between, the angle between 180 degrees and 150 degrees. What is that? 180 minus 150 is 30. So that means the reference angle for 150 is 30 degrees. What does that mean? The point where the 150 angle meets, it will exactly be the same point as here. It will be cos 30 and sin 30. The numerical values will be same, but then what? The sign will depend on which quadrant it lies. Now, which quadrant is this? This is the second quadrant, which means only the sign and its reciprocal cosec will be positive. All the other trig function values will be negative. So what do you have? The cos of 150 is minus root 3 by 2. Its sine is what? Half 1 by 2. And all the other functions, all the other trig function values also follows. So what do you see? Here 30 will touch at root 3, 2 and 1 by 2. Now I have taken another one angle, 315. Where does 315 fall? It falls between 270 and 360. It falls in the fourth quadrant. Then what are its sine and cos values? For that you need to find its reference angle. What is its reference angle? Its reference angle is the angle made by 315 and the nearest horizontal axis. Now don't go all the way to here and subtract 180 from it. Don't do that. You will get the correct answer, but then the angle will not be an acute angle. You see what happens? If you go over here, you are crossing over the one of the axis, which means you are adding a 90 degrees to your reference angle. At that time it stops being a reference angle. Your reference angle should be an acute angle. So if you take 315 minus 180 and say this is the horizontal axis, right, the answer is correct, but it will no longer be an acute angle. So subtract 360 minus 315 and what do you get? You get 45 degrees. So all the trig function values of 315 are exactly the same as 45 degrees, but what? Only numerical values. Only the numerical values are same. What about the sign? The sign depends on which quadrant it lies. This is the fourth quadrant, which means only the cos and its reciprocal sec are positive. All the others are what? Negative. So this The cos 315 is 1 by root 2. Its sine value is minus 1 by root 2. Now this is how the chart for the reference angles look like. If your angle is in the first quadrant, you have no problem at all the trig function values are well defined. But if it falls in the second quadrant, what will be the value of your original angle? It will lie between 90 and 180 degrees. So suppose this is the angle that we are worried about. We don't know what its trig function values are. Then what will be its reference angles? Its reference angle will be this distance, 180 minus that angle. Suppose randomly give me an angle, say 100, right? So this angle will be what? 80 degrees. So the reference angle for 100 is actually 80 degrees. Now what if your angle falls in the third quadrant? Then the value of your original angle, the one which is worrying you, it will be between 180 and 270. And what will be its reference angle? Its reference angle will be that angle minus 180. And for the third quadrant, this is how your reference angle looks like. Now one mistake that I have often seen children making, for example, I have to say find the value of randomly say 220, right? 220. Sometimes I see them going all the way here and subtracting 360 degrees minus 220. Don't do that. Your answer will be correct, but it will not be an acute angle. If you see 360 minus 220, your angle is going to be what? Again, it is going to be an obtuse angle. Your reference angle should lie here in the first quadrant. It should be making your life easy. It should be an acute angle. If you are subtracting 360 minus 220, you will again get an obtuse angle. Then again you have to find another reference angle for it. So remember, go to the nearest place. Go to the nearest x-axis and find the reference angle. What you need is an acute angle. And another thing you would have noticed that all the angles that we are taking, we are only taking specific angles which are the multiples of 15, right? 15 into 2 and 30 and 45 and 45 and 60, they are all multiples of 15. Then I know you must be wondering, how do I find say sine 27, or in this case it is what? It is 100. So how do I find tan 100? Now all I know is that for 100 the reference angle is 80, right? So trust me, that is enough. When you go to higher classes, you will have a table. It is a book. You will have a table. In that you will find all the trig function values for all the acute angles in the world. Whatever you can think of, it will inshallah be there. So don't worry about this. We are just learning the beginning. In the beginning stages, you only have to worry about angles which are multiples of 15. Now here I have taken the unit circle, and when it completes a revolution, how many angles does it cover? It covers 360 degrees. Now let me divide it into 12 equal parts. Then what? Each part will be what? Each part will be 30 degrees. So one part will be 30, 30 into 2, 30 into 3, into 7, into 10, and the final part will be what? 30 into 12, which is 360 degrees. Let us first draw those angles. So I have taken the unit circle, divided it into 12 equal parts. Now look at all the angles which are near the horizontal axis. All of them will make an angle 30 with the horizontal axis. Here a 30, here a 30, here you have a 30 degrees, here you have a 30 degrees. So all of those will have the same numerical value for the sine and the cos. And what will be different? Their signs will be different depending on which quadrant that they lie. Now take 60 degrees. Here a 60 degrees. Here you have what? 180 degrees minus 120 degrees, again a 60 degrees. So all of them will have the same trig function values as 60 degrees. All of this will have the same trig function values as 60 degrees, but remember only the numerical value. What about the sign? It will depend on which quadrant it lies. So there you have. So you see what is happening here. We have taken the unit circle, divided it into 12 equal parts, and what do you see? Their trig function values are reflections of one another. Here you see all these values are reflected here, and if you cut it across here for all the values in this level, just put it like this, you will see that all the values here, a root 3 by 2 and a 1 by 2, the same value here, and this value here is the same value here. So you just, if you know the important values, the trig function values for the acute angles, that is all you need. You just recreate it here. It is just a reflection here, you can see, but remember the reflection is related only to the numerical values. Signs, remember to change the signs accordingly. But now we have just one more section. This is into what? Into 12 equal parts, right? So just one more small division where we will divide it into 8 equal parts. That is just to find the values, trig function values of 45 and its multiples. There, once again we took 360 degrees, divided it into 8 equal parts. That means what? Each part is a 45 degrees. A 45 into 2 into 3 into 4, you go like this all the way. 45 into 8 will give you the final one, which is what? 360 degrees. Now what all angles do you see which make the same angle 45 degrees? Here a 45 degrees, here again 180 minus 135 will again give you a 45 degrees here. So here there will be again a 45 degrees. So what do you see here? Do you see one important fact here? In every quadrant there will be one special angle which will have the same trig function values as 45. This is not just for 45, for 45, for 30, for 60, for 25, 27, whatever acute angle you have, in each quadrant, in the second quadrant, in the third quadrant, in the fourth quadrant, you will find an angle which has the same trig function values, numerical values, but its sign will be different, but the numerical values will be same. So it periodically it keeps on changing. The same value keeps on repeating. That is what we learn from this. Now all good things must end sometime. It is the same with our class today. It is time to wind up. What did we learn so far? Why are we considering a unit circle and not a unit triangle, not a unit quadrilateral? Why? Because trigonometry is basically the study of right angle triangles. To be more specific, it is the study of the relation between angles and the ratio of sides of a right angle triangle. Now, with unit circle, if you randomly take any point which looks like this, then this can be visualized as being a part of a right angle triangle in such a way that both of its coordinates become two sides of that triangle with the radius or the hypotenuse as 1. So it looks like this, or in other words, each point in this unit circle can be visualized as being a part of a right angle triangle. That is exactly why unit circle is very important in trigonometry, because it is closely, each and every one of its points is closely associated with right angle triangles. Then what else does it do? It gives you an extension of the domain of the sine and the cos cos function. Now in case you have not yet heard of the word domain or range, do not worry, it is a very simple concept. The domain of any function, here f is the function, the domain of any function is all the values that this x can take. Suppose fx is equal to x minus 1, then the domain of f is all the values that x can take. Now what all values can x take? It can be negative, it can be positive, it can be any real number except for what? Except for the number 1. It cannot take the number 1, because if you put 1 here, it will be 1 by 0. Such a thing does not exist. Your fraction cannot have 0 as its denominator. So the domain of this function is any real number in the world, but just leave out 1. Now what was the problem with our sine and the cos function? The way we defined our trigonometric functions, unfortunately, what did we say? It had to be acute. Your theta had to be between these two numbers. Now that is what unit circle has helped you with the introduction of the concept called what? Reference angles. With the help of reference angles, whatever your angle is, be it less than 0, more than 90, whatever, not just for this quadrant, wherever your angle falls, with the help of the unit circle, with the concept of reference angle, now we can find the sine and the cos function values. Not just that, here I have written sine and cos because in this class we studied only about those two functions. This works for any trigonometric function. All the 6, there are 6 trigonometric functions, right? For all the 6 of them, with the help of unit circle, we can find their value. And what else did we learn? We learned how to represent any angle on this circle. Not just that, to find the relation between the angle and their sine and cos functions. Now here I have written only sine and cos because that is what we covered in this class. But like that you can do tan and sec and all that, but inshallah that is for another class. Now what did we see? The angle where it meets the unit circle, that point on the unit circle actually denotes the sine and the cos function. How? The sine of this angle will be the y coordinate, the cos of this angle will be the x coordinate, and this way we have found a relation between the angles and their sine and their cos function. That is what we saw. And what more is it? It is basically visualizing the periodicity of the sine and the cos functions. What do we mean by the periodicity of the sine and the cos function? Which means that after one complete revolution, which means after you cover 360 degrees, the values get repeated. Now remember, this is only for sine, cos and their reciprocals, which is sec and cosec. It does not work for tan and cot. They have a different period. 2 pi or 360 degrees is just the period for sine and cos only. Now for sine and cos, if you complete one revolution, for example, I will start with 30 and I will complete one revolution, which means what? I have started at 30, which means 30 plus 360, which means 390. Now 390 ends up at the same position, which means cos of 390 is root 3 by 2. Sine of 390 is 1 by 2. Now it is not just for one revolution. You can keep on going, 360 into 2, 360 into 3, keep on going. As many revolutions as you can make. Suppose you are making 2 revolutions, which means what? 720. Add 720, then you get 750. 750 ends up at the same place, which means what? Same sine value, same cos value as 360. Now this is you going in what? Anti-clockwise direction. So you are taking positive values. What if you go in the clockwise direction? Now the first journey we went in the anti-clockwise direction. You remember how we differentiated the positive and the negative angles? If you go in the anti-clockwise direction from the bottom to the top, we will add, that is for positive angles. But the same journey if you go in the clockwise direction, which means from top to bottom, it will be negative. You should subtract. Now do the same thing. End up where you started, and then what do you get? You get a minus 360 because you are going in the opposite direction, but no problem. The concept is still the same. You have ended up in the same place, which means the same cos value, the same sine value. Now this is a very simple way, a very basic way to visualize the periodicity of the sine and the cos functions. But then in the higher classes, inshallah, you will learn a more effective method, which is the graph. The graph and the sine and the cos functions is a very effective way to learn the periodicity of these functions. The graphs are inshallah for another day, but for now it is time to wind up. Till I meet you again, you take care. Assalamu alaikum.